Alors, bonjour tout le monde, je me présente Claude Labbée.
Good morning, everyone. I would like to introduce to you Claude Labbée, Director of the Drawings Department for the Britton Company. First of all, I would like to thank the CanBIM committee for giving us the opportunity to exchange with you. So we'll hear the perspective of the subcontractors. So to start, I would like to introduce you briefly the company for those of you who don't know it. So Électrique Britton is an electric contractor working mainly in Montreal, but he also works throughout Quebec and in Ontario. So the company will celebrate its many years of existence next fall. So we have a service division and construction division. So for the service division, we have a fleet of 30 vehicles, so oftentimes we have comments on the color of the truck. We like it or not, but when we see it, we know immediately that it's a Britton truck. So the service division does a preventive maintenance, registration of power, so the width of the pipes. I'm sorry, I'm nervous. It's the first time I make a presentation in front of such a big audience. I hope you'll show understanding. We have two types of project, plans and specs, and also a clé en main. Turnkey projects. Now, the turnkey projects account for approximately 15% of the projects we carry out. The company had a very high peak in 2015 with 800 employees with more than 1 million man-hour declared at the CCQ. So we're the biggest contractor in Quebec. So Britton works in several business sectors, commercial, institutional, residential. If we have a brief list of the projects we were involved, Block B, C, and E, Shriner, CHU Saint Justine Hospital. So we installed the distribution, so specialized buildings and research center. We built a few centers, 10 floors, Ericsson, ICD, and Vaudreuil. Now, in the condo and office towers, we were involved in a building of 36 floors in the mode design and build, Quarter Evolution, Balmoral, which is now in construction, undergoing construction. We participated to the reconstruction of the Queen Elizabeth Hotel. We started in June 2016, and we will complete this work in June 2017. And finally, the Canadian Tower. And another tower, we had two towers of 50 floors each. We developed areas of expertise. We have specialized teams in high voltage and in automation. We're representing Lutron, industrial control. So we can build panels ourselves in workshops. We have specialized teams in automation design and automation and simulation of lighting. So many members of my team were involved in the training at the ETS Montreal. So we carried out lighting simulation with G42. We also have an engineer team that can carry out all sorts of studies, coordination, arc flash, measuring, etc. All these people work in building projects and renovation projects. So for external services, we are there. We are available for potential clients who would need our services. Now, if we start with the implementation of the BIM process at Britton, it started in 2013. First of all, we had a course, introduction of the implementation of BIM with two professors who gave us very good directives in terms of implementation of the BIM, which was essential. Then we called upon our contacts or our network of contacts to obtain more avant-garde information with companies who had already implemented BIM in their companies. We also called upon consultants who guided us in order to set the basic standards in order to be able to start with a solid foundation. The objectives sought by the company: improve the coordination process, have a better overview in 3D, reduce conflicts between systems, ensure a better monitoring of the changes, and detect the problems at an early stage. So following the implementation, the best thing is to put in practice what we learned. Instead of doing it with a small project, we started with the project Ericsson ICT Global in Vaudreuil is the biggest contract that the company obtained. So we started really big. So it's an informatics center of 400,000 square feet. 6 months after the implementation, well, it's the first project we started working on. So it's one of the third major centers of the Ericsson data center. The others are located in Sweden, and they were built in 2014, 2015. Now, the geographic location in Vaudreuil. Why Vaudreuil? In fact, in Vaudreuil, we have high-voltage Hydro-Quebec lines, so the IT center needs a lot of energy, a lot of power. The building is fed by two transmission lines, distribution lines, 2.5 megawatt each. So now, if we have stats on the power consumption of the building, 14 megawatt, which is the equivalent of the power necessary to heat 4,000 houses. And once the center will be fully operational, it will be the equivalent of 20,000 houses that's needed energy-wise. Also, ventilation system could cool 1,400 houses 6 months a year. So in Canada, we have the advantage of offering a energy energy saving, because we have a very, very cold climate. So the project spanned 18 months, and we called upon 250 electricians working on shifts in order to succeed. In fact, this concept is executed in 2D, and the contractor had the mandate of 3D coordination with specialized contractors. Various platforms were used by the different disciplines. So CAD map, HydroCAD, Revit, all the models were integrated, and we also simulated the conflicts. It was not a complete modeling. It was only coordination of the equipment and the ducts, and also the switches were not looked after because we did not have enough time. Now, so we used 6 modeling system, and we also called on subcontractors. We had a few drawers who had undergone training, but we did not have enough to meet the demand, so we had to go outside. So the length of the project, we modeled up to 60 kilometers of cable ducts, and there were transformers and other devices were also looked after. So obviously, we heard this information in other conferences on BIM. So obviously, the draftsmen knew very well BIM. They did not necessarily have the skills in order to master or control the duct networks. So we used, in fact, paper copies that were transferred to the BIM team. So they had the plans. The second project in which we were involved for BIM, it's the Bell Place in Laval. So we have 500 seats, and you see here this project started in January 2015. Here, the mandate was much wider. All these systems were modeled. We had decided that we would model the 2-inch ducts and more. And in fact, we went more in detail, but it was essential for us that we did not have to model everything. So we tried to work at a great level of details, and we monitored closely what was going on site. So we had to use a second BIM team because the project would not have been completed. So in parallel, we set up a second team. So it had been decided in the project of the Place Belle that the building would be divided in 2 models. And here you see a list of all the various models that we found that could be found on the project. Here, most of the contractors had not been trained in BIM, so it's a firm that was to recover, in fact, the drafts or the drawings that had been made in BIM. Since we knew the BIM system, we were able to model the electric equipment and fire alarms, etc. And we also, and they had to validate all the design and sign off the plans at the end of the project. Pomerleau controlled the modeling of the equipment that had been provided by the client. Also, for this project, we went much further because we had to use the function of the circuits. We had to monitor the voltage, etc. So the mandate was much larger than we thought. So we had a BIM coordination meeting once a week, and we showed the model once a week. So in 2 or 3 days, we could get the necessary information. I attended these meetings, a coordination meeting, with my laptop because at a distance I could have access to the information. So if a panel was not well installed, I could install it myself or correct it myself live with the model I had at the office, and I could also have the screens that could be transferred directly to the team with the position of each and every one of the conflicts. So it was easy to communicate all the necessary relevant information to the BIM team. Coordination of interferences. Simon Brunet, who is here today from Pomerleau, who transferred the list of conflicts. They were numbered and assigned to each and every one of the contractors, and we had approximately a week to try and solve the conflicts before the next meeting. And we dealt sector by sector in setting priorities for priority zones on site. To do this, we could make notes, and if, for example, if there was a conflict between 2 contractors, it was easier for me to say something. I made the comment directly in glue, so this solved the conflict. So it's important here to follow closely the rhythm of the other contractors, because if you lag in your work, it's difficult then to catch up. So you have to put in place the necessary teams to be able to follow what's going on site. So here you have examples of screenshots. So this can be sent by email, so it does foster the exchanges instead of putting a note on a CAD plan. So we have screenshots, then you can make rapid decisions with the various stakeholders, and you can come up with a very precise or accurate coordination with this. Communication with the site. We used tablets in order to allow the team on site to follow the evolution of the model. Well, we didn't use paper because just the fact of printing it is already outdated. So it's important to have digital platforms or tablets to be able to recover or retrieve swiftly the information. Also, oftentimes, the systems have not been built, and they have to plan smaller ducts that have not been modeled. So they have to go back to the model to see what space remains available to install the smaller components that had not been planned for. Also, communications to people on site. We were able to get to a good level of details. Everything has a number. There's a reason why a switch is located at a specific place. So we provide the code for each component to make sure that the coordination is monitored. So we detail the installation with the heights, etc., and the various details. Sometimes the position of the switch, in fact, is not at the right. It is not well placed, aesthetically speaking. So to make sure that people on site follows closely the instructions we gave them, it's important to code everything. Now, technological tools. Increasingly, we use automated system for the openings and the anchors, supports, junction points. It's not only in the context of a BIM project, but also for CAD projects, we increasingly use the system to install things as soon as possible, and the performances are great. So, and this was for switches and sleeves. So, other technological tools. So, we used 3D digitization for existing buildings. There was a project, the model of which had been made based on surveys, on readings. There was a difference of 8 inches concerning the measurements of the various parts. It was a mistake, so we had to have a 3D model to validate the architecture, to validate the dimensions of the existing components. We didn't have to do some readings on site. So we could reuse the information to know, well, we used various phases to check what equipment could be displaced, what equipment could be dismantled. So we used various phases, installation of temporary equipment to heat the building during the work. Here we were able to use various scenarios, so design options. We were able to simulate various scenarios to try and find which combinations were best adapted to the project. So we were not obliged to do more plans. So we had the same model, but with different design options. Now, electrical coordination without the BIM. In some coordination work, you need a lot of specifications. For example, if you have in fact, now, when we know the capacity of BIM, we cannot go backward. Unfortunately, over the last 3 years, we were involved in many major projects, plans and specs where there was no electrical coordination with BIM with the contractor. Without this, the models were refused. So to be able to make the coordination of the electrical circuits and all the structure, the armor bars, you have to have basic coordination with the margin of error that we have to reconvert to model, monitor it, change the structure and the architecture. It would be a waste. We invest money to have BIM, but oftentimes we can't access the model. So it's important that the contracts force the clients to transfer the model, because it's very frustrating to know that a model exists, but you cannot access it. I heard some answers about that, in fact, previously, but I would like to know why we are faced with such situations. It's going to be a major obstacle for getting BIM in. Contractors who have not adopted BIM yet, the advantage to do so is very limited. So advantage of BIM, prefab. In the electrical field, in fact, we have some catching up to do for ventilation and plumbing. They're much more advanced. For ventilation cannot be done on site, but sprinklers have to be used 100%. Electricity, in fact, we use it very little. Well, the advantage offered by BIM will allow us to go further, and it has a lot of benefit from the perspective of construction. We have to come up solutions to foster the installation. So prefab is the solution. Here you have an example of prefab that was done at the Place Belle. All the trajectory of the cables, each of the section of the cables was identified with the height, the length. So they were all pre-cut in the plant, the supports as well. All the supports were modeled, seismic standard, seismic support rather. I know that not all contractors go to such a level of details, but for our project, we thought that it would be very beneficial to do so. Now, when we do not model the support, oftentimes you look at this, everything's rose and dandy, there's no conflict, but when you go further analysis and you start to analyze your supports, well, you see that not everything was thought of. The fact of modeling the support, in fact, allows us to go more in depth with our analysis. So the advantages of the BIM that we were able to recover in the project of Ericsson ICT and Place Belle, we were able to coordinate the support and, from a seismic point of view, supervise the electric charges and see whether there were surcharges in some places. We were able to generate identification of our equipment and do that automatically. Estimate the length of the cable more accurately. So power cables are pre-cut, so it's important to be able to estimate this accurately to avoid losses and waste, and also early resolution of conflicts. So we were able to solve many conflicts, many problems with this. No, for the BIM, the model, the more the model will be advanced, the more we will use the margin of error. All this depends on the capacity of the BIM team to get to a certain level of details, because this is what gives us more accuracy. And this is very relevant, very necessary for a project. Now, the future of the BIM in our company, obviously, we looked at all the functions with the projects I presented to you. We were involved in some smaller projects using BIM, smaller scope projects, but in the future we would like to increase the implementation of BIM. We will be able to calculate the lighting system using a model instead of using a software, and also we will be able to deal with the tension drop. We will be able to put in place quality control model using LOD to make sure that there is monitoring and that we have information at all level and at all phases in order to avoid forgetting things. Now, the future of BIM in electricity and in our company, first of all, we would like to add to the basic functionalities or functions of BIM. Increasingly, it has to be more versatile. Well, we started using it in 2014. It has evolved, and now we will be able to take advantage of these Some manufacturers, if we have specific parts, it would be fine that these parts be manufactured directly. Recover the color of the walls to be able to, from an aesthetic point of view, to have the good color for the switches and also for the color of the lights and all that everything be fine from an aesthetic point of view. So this was a brief overview. Obviously, we made a lot of progress over the last years. We still have a lot to do. We're just at the very beginning of this adventure, and we hope that the sector of construction will go on using BIM increasingly because we see a lot of advantages to this method.